Hi, good evening to all. Today's topic is all about the simplex method. So we have a problem. The subjective function as is that the equal to 3x1 plus 4x2 and two more equation for the subjective constraints. And there is a conditional the equation x1 and x2 the greater than or equal to 0. So directly we can go to the solve the problem. So we have to then add the slack variables as the S1 and S2. The standard of LPP now will be as follows. So objective function would alter as 3x1 plus 4x2 plus 0 into the S1 and the 0 into S2. S1 S2 into S1 S2 now would be a slack variable here. Then subject to the constraints now 4x1 plus 2x2 plus S1 equal to 80. So we got to the change the inequality to equation. So for that purpose we have to add the slack variables. So the equation would be 4x1 plus 2x2 plus s1 equal to 80, as well as the second equation. So optimality condition x1 x2 the s1 s2 now greater than or equal to 0. So initial solution is obtained by taking x1 equal to 0, x2 equal to 0, so that s1 equal to 80, s2 equal to 180. After that we got to try a simplex table. In that table the headlines would be the coefficient of variables, basic variables and solution values, and the objective function on the top along with the coefficients. x1 coefficient 3 and x2 the coefficient 4 and the s1 coefficient is 0 and s2 coefficient 0 under the minimum ratios. So first we got to now write down s1 s2 values. So s1 equal to 80 and s2 equal to 180. So s1 coefficient 0 and s2 the coefficient 0. It has mentioned on the first column. Second column the basic variable s1 s2 and solution values 80 180 we got from the equation after solving the equation. Then 4 is here now throw the subject to constraint the equation as a 4x1 plus 2x2 plus s1, that is 4 to 1 here, and 250 as well, 251. So we got to now CJ, we got to the multiple in the CJ value and the solution values. So 0 into 80, 0, plus 0 into 180, 0. That's why they here the 0. And the second the 0 into 4, 0. So if you add the something with 0, its the solution would be 0. That's why ZJ value is not totally 0. Then we have to subtract the CJ value from my ZJ value. For that we have to subtract the objective function through the CJ value. So 3 minus 0, 3, 4 minus 0, 4, and 0 minus 0, 0, 0 minus 0, 0. So we have to now find out the maximum value through this table. So here is now 4 is the maximum value. So it will come, it will enter into the second table. So we need to now find the departing variable. For that purpose we got to calculate the minimum ratios. For that purpose we got to now divide the 18 by the intersect element. Intersectional element is here 2, so 80 divided by 2, 14. as well as 180 divided by 5, 36. Through which now we got to now find the minimum value, minimum ratio, that is now 36. So corresponding now the minimum value is the S2. So we have to now eliminate S2 as a departing variable. 3, 4, and 0, 0, it's not a optimality. So we have to achieve our optimality, then only the table will be now completed. So we got to draw second table. So in here now, x2 enters under s2 departs. So for that purpose, now we got to draw a second table. So to find out the S1 value, here is the x2 enters under the s2 departs. To find out the enter values, the formula is the values of entering variable x2 equal to values of a departing variable divided by intersectional element. Here is now a departing variable, which means the S1 variable 180,2501, which would be then divided by the 5. So the final entering variables are 36, 21501 and 155. So we can write down those values on the table, like 18, 36, 2 by 5, 1, 0, 155 and 19. Then we got to find out the S1 variable. For that, we got to apply the following formula as the value of S1 equal to old value of the S1 minus the intersectional element multiplied by values of the entering values. Here is the old value of the S1 84,210. Then we got to minus by intersectional value under the value of the entering value. Here is the intersectional value is 2, 36, 2 by 5, 1, 0, 155 are all the values of entering variables. After solving this equation, we can get the problems we can get the values are as 80, 16.5, 0, 1 and minus 2.5, 2 by 5. Those values we can apply on table as 18 and 16 by 5, 0, 1 minus 2 by 5 under the 552. No, not 552. Until minus 2 by 5. The rest of the rules whatever we have followed the previous table. After that, we will get one in a positive value. Optimality procedure would be all of the Cj minus the Zj value either the positive or either negative or 0. Here is one positive value as 7 by 5. So we got to prepare another one table. So another simplex table as it is the third table of the simplex. Here is the x1 enters under the s1 departs as per our in the previous table. So the formula would be the same whatever we followed for the second table as well as the third table. After solving this table, we can write down our conclusion as since all index row elements are 0 and negative, it is the optimality test. Once we achieved the optimality, so we reached the optimal solution. So the optimal solution is the x equal to pi by 2, or else we can mention as 2.5 as well. x2 equal to 35 and the maximum cost is 147.50. It is our final conclusion. Thank you for your patience. We will see you another session. Until then, stay tuned, stay blessed. Bye.